Limits can be quite tricky to deal with. However, if we apply the rules consistently, then it should be reasonably straightforward. These are some of the examples from the textbook, and we're going to look at a couple of these. First of all, we want to evaluate the limit of this function as x tends to c. To do this, we apply the power law of limits. That is, if we want the limit as x tends to c of some function g of x raised to an integer power n, then that's just equal to the limit as x tends to c of g of x raised to the power n. So in this case we can define f of x as being equal to g of x cubed, where g of x is equal to x squared plus 1 over x. Now that's a very easy limit to evaluate. We've got the limit as x tends to 2 of g of x is just equal to 4 plus a half, or 9 over 2, and therefore the limit as x tends to 2 of f of x by the power law is equal to 9 over 2 cubed, that is 729 divided by 8. Now let's look at another example where there's a complicating issue, is the fact that for this function the denominator tends to 0 as x tends to 0. So we want to evaluate this limit. So the way we can do this is by expanding the numerator of this expression and noting that we can cancel the 4's here and then divide through by x to write it as 4 plus x. Now once we've done that, the problem disappears and we've got the limit of f of x as x tends to 0 is just equal to 4. So by an appropriate transformation we can make the limit relatively straightforward.